I start studying astronomy, that'll be the whole day. The whole day will go doing that, you know, or cosmology. Oh, I love it. I love the universe. I was talking to somebody yesterday and I realized that I don't know condensed matter physics. I mean, I already knew that. I just reminded myself, or I got reminded that I don't know condensed matter physics, right? So, because I did physics and then I did more astrophysics, and in grad school I did I did a few rotations. I did a little bit of condensed matter physics and then cosmology, and then particle astrophysics is what my PhD is in. So I really don't know much condensed matter physics. It's a subfield within physics that I don't know much about. It's like the material C type of stuff, like graphene, cool materials, unique materials. So that's like that's actually kind of like cooking, you know? It's something very useful, but I don't know much about it. That's because you have finite time to do everything that is enjoyable or that that you can really gain expertise on, you know. It's not like you never could. You just have to put the time in to get into it. More money involved in condensed matter, probably. Steven, how are you? John says more money. Nice. That's cool that you have determination. Can someone give her a super chat? Yes, please. Can someone give me a super chat? So that I know that it works. It can be like $1. I don't know. Or maybe $1 is a lot of money, depending on the country you're in. You're growing on me. Aw. Thank you. Tiptoed in, hoping not to be seen. Too late. Aw, Steven. You're not too late. Class starts when you're here. But I am spoiling you. She's rich. She doesn't need super chats. Doro, I will ban you if you continue in this line. Steven says, hi, Reese. Yes. Full class is here now. I have no class. What do you mean? What do you mean you have no class? Oh, you have no class. Oh, like status, you mean? I'm like, what are you talking about? So I teach astronomy, physics, cosmology, all of that. That's what we're talking about right now. She isn't rich without the proper knowledge of cooking. That is true. Abundance is of many types. I'm broke, lol. I need to get another guinea pig. Oh my God. See, Steven is so funny without trying. He never says bad things. He never swears. He never says like weird comments, but he's so good at astronomy. He's so curious. He's mostly on time. And here he is. Thank you, Steven. Thank you for being here. And Steven and me both have been to the hospital recently. So hopefully we're on the mend. Today I went to the gym for swimming for the first time since all that happened, Steven. So there's hope for us. Steven has said plenty of bad stuff. It's why I love him. He has not said anything that's like unreadable. Has he? Maybe I just haven't seen it. Like he says stuff that's PG-13, I think, right? Excuse me? I saw some live stream last night where the guy got his girl. Some drunk guy came over and poured then he got $300. Doral, given that you're so rich, can you donate $300 right now and sponsor this live? That would be amazing and a good use of your money. It would be a great investment, and you can help to keep this channel going. Doro here is a very important guy at his job. Okay, so we talked about... Oh, can you please like the live? Can we get 20 likes? So help me and yourself by acquiring the rich knowledge of cooking so your new viewer would support you endlessly. Sure, hold your breath. Do you take food stamps? Do you take food stamps? Sure. I mean, I don't know yet about that, but sure. Like the live. Yes, please. Can we get 20 likes? Stephen breached all the watertight compartments. You got my like. Thank you. Verse says, I'll die. Why? What happened? What, Stephen just put a weird comment? What do you mean? What did he do? He did not put a weird comment. No way. Stephen is the man. Can we get 20 likes? I've been having too much fun reading your comments today. Oh, so by the way, yesterday, I believe somebody asked about the spin property in quantum mechanics. And oh, no. Doro said to hold my breath. I think about the super chat. And I know you're not going to cook anytime soon. I might. I mean, I do need to eat. I do make food. I just don't cook. So you never know. I said I sank the Titanic. I was the iceberg. Oh my gosh, that's right. So everybody who's new to the channel, meet the regulars in the chat. They have a whole storyline of their own that they keep on doing when I am reading and teaching astronomy and cosmology. So feel free to make friends. Stephen was the iceberg half spin you mentioned. We all want election stream part 2. I did do an election stream on election day. It was quite, what's the word? It was quite spontaneous and unfiltered. So you can feel free to go find it during that time of the year, November-ish, I think it was. I use good old microwave for cooking. See, this is why Stephen and I are friends. Stephen understands me. Stephen gets me. Thank you, Stephen. Thank you. Storyline is real. Rose is evil. Who the originals? Harper, thank you so much for being here. Microwave rules. Exactly. So I wanted to address real quick, because I know that we were talking about superstring theory yesterday, which I still need to get some more books on it. I had too much going on. Guess what? I did my taxes today for last year. So that took up some of my time and I couldn't do as much as I would like to do for the channel today. But I did do my taxes and I needed to. And if you do your taxes, by the way, if you're in the US and if you do your taxes early, then generally you can get a discount. And I love doing my own taxes with the help, of course, of TurboTax. TurboTax, if you want to sponsor this live, go ahead. Feel free. Currently, they're not a sponsor. And so I used TurboTax and I did my taxes today. So I got busy with that. So I still need to find more books on superstring theory and get more context for that particular topic. It's difficult without finding more relatable topic on that on superstring theory, because it's a very mathematical, geometry, very abstract kind of subject. So it'll be difficult to just kind of talk about it without going into those types of details. So she did her taxes. She's mega rich now. I burn water on the stove. I need to do mine and hear about string theory. Yes, do yours. TurboTax, exactly. So if you use TurboTax and get it done by February 28th, so this was my deadline. I wanted to get it done before February 28th so that I can get this discount. I freaking owe money on my taxes. She isn't that rich. She knows why. She is super rich. She makes a mean chickpea. Now I'm getting hungry. I might make the chickpea again. I hope I don't owe money, but I will go to Jackson Hewitt, Walmart. What? What are you, what's wrong, John Foster? I do make a mean chickpea. You're an iceberg, you don't do taxes. So, yeah. So I'm giving you guys sort of a, announcement right here. If you want to do your taxes and get a discount filing your taxes with TurboTax, the deadline is February 28, midnight. If you file before then, it will be discounted. And so I did. And today was the day for that. Rose drowned my taxes. She ain't making filet mignon rich. She making chickpea rich. February 28, I don't have that much time. I gotta work and stuff. Okay. Filet mignon. Okay. So, what is the current status? All right. Before I forget, I keep forgetting. So, Reese, you asked about the quantum property of spin. I thought about it a little bit more. So basically, for all the particles that we discuss under particle physics in the standard model, like say, for example, electron, positron, which is the anti-particle of electron, neutrinos, muons, taus, basically, in quantum mechanics, each of the particles have certain properties. Like the way to think about it is that they have certain properties. Some of the properties might be more popularly known than others, but basically spin is one of them. So mass is one property that will distinguish a particle. Charge is one property. Spin is one property. So those are the different properties that you might come across, and the spin of fermions is different than the spin of bosons, and also depending on so let's just say once you get, for example, an electron, depending on its mass, charge, and spin, you will know that it's an electron. If you compare it to the positron, which is its anti-particle, then the mass will be the same. The spin might be the same. I mean, there's only two possibilities. It'll be one of those. The thing that will be different is the charge. So that's kind of something that will distinguish or make you be able to, that's what makes the particle distinct from each other. And the particle's state, it's kind of like the quantum state of the particle is given by those things, the mass, the charge, the spin. In some cases, there is another property as well, depending on if it's a quark, right? So once again, just a quick recap. The particle family, there's three types of particles. There's leptons, quarks, and bosons. Once again, an example of a lepton is the electron or the muon or the tau or the neutrinos. Actually, there are three flavors of neutrinos that we have talked about as well. So that's in the lepton family, Lepton. Then there's the quark family of particles. Quarks are another whole type of particle, and examples of a quark would be the up quark or the down quark, things that make up stuff like our protons and neutrons within an atom. So subatomic particles, or really the nucleus of an atom, has more particles in it, protons, neutrons, which break down further into these things called quarks, which are in that family. Lastly, we have the boson family of particles. This includes things like the photon. The photon, which is of course light, is the particle nature of light, is a photon, is an example of a boson. All of these particles that I just now mentioned, so all of the above, when you write down the quantum state of a particle, you will have things like its mass, the charge, and the spin. And in the case of quarks, there's one more property. But hopefully that kind of makes it a little bit more clear what I meant. Basically, think of it as an identifier. If I tell you the mass, like say if you didn't know that it was an electron, but I told you its mass, its charge, its spin, then you could tell me that it's an electron. Okay? Stuff like that. But the electron is a very common example. There could be other particles that are not as well known, or wasn't as well known, or wasn't discovered. And this is actually how many more types of particles were subsequently discovered. We kind of talked about that from that book that I was referencing yesterday, which is that there was a time in the 20th century, in the late 20th century, where pretty much almost every day we were discovering a new particle, or so it seemed, okay? And there's quite a bit of diversity and sort of variety and possibilities with these types of quantum states, like when you change the state and get a new value, say like you find, I'm just saying, you could think up a particle, right? You could think up a particle which has maybe the charge of an electron, the spin of an electron, but like a different mass, right? And in fact, that's actually how we discovered more types of leptons, right? It's like, oh, same charge options, same plus or minus charge, basically, either because photons are neutral, like they don't have a charge. So like, what are the charge options? It can be positively charged, negatively charged, or neutral, right? So if I tell you this particle has a negative charge, it's not a photon, right? Like that's out, like it can't be a photon, right? So it's almost like playing, what's that game where you try to guess it? Something like dumb charades or 20 questions or something where basically, or what's the game where you basically try to say, oh, this, it's an actor. Yeah. Say it's an actor, but you try to say exactly like guess who type of thing, where you're like, okay, this actor was in the Titanic. This actor is female. This actor is very well liked in this live chat. So this actor played Rose. This actor must be then, this actor drowned her boyfriend. So it is, what's her name? Kate Winslet, right? So that's how you know that Kate Winslet is Kate Winslet. Well, it's not Rose. She played Rose. Right? So the same thing, oh my gosh, I think this worked out. This example actually worked out. You is smart, you is kind, you is important. Oh, thank you, John Foster. I will admit, I don't think the US is ready for a woman president yet. Are you guys still talking about politics? I wanted Kamala to win, Harper says. Thank you, Harper, me too. I can't believe Wendry wanted Kamala to win. Why is that unbelievable? What do you mean? Can we get 20 likes? The current state is 2gmc squared calculating. So if you could zoom in optically on a particle, it would be physically spinning. No, not really. It's not really spinning physically in that sense. What are the properties of my depression? I think the properties of your depression are, I don't know about the properties, but the causes might be that you have a corporate job where you got promoted too much. When will Rose stop her reign of terror? She ain't rich. You could change that verb by donating right now. I don't really believe in things staying the same, if you know what I mean. Dynamic. Physics is about writing down the position of a particle as a function of time, meaning that we expect it to change. Same thing about my richness. Let's see. Women rule, but Rose is evil. Rose is basically what's wrong with women. I really need to watch Titanic again. I I can't remember exactly what she did wrong, other than not sharing. You're beautiful, pretty smile, and great face. You're wise. Thank you. Thank you, Cirque and Lilith. Love that name, Lilith. I hated Titanic, the J. Cameron version, but will always love A Night to Remember and the Nazi Titanic. Come on, people. We need a super chat. Yes, we do. Thank you, Harper. Thank you. You liked Kamala. Let's share our wealth. Harper is a kid. Come on. I'll donate you a new stove with fire shields. She did a few things wrong. Share all the wealth, Kamala. Doro, I'm broke, okay. Okay, so similar to this rose thing that we just did, I love how half the chat is just about Titanic at this point. Cheat and have a guy she liked die, took the fiance's jewelry and kept it. Oh, did she do that? I was a kid. I didn't really follow all that. You know what I mean? So she cheated on her fiance and she kept the jewelry and she let the guy die. Okay, I see. So just like we figured out by those different properties that we're talking about Kate Winslet, the actor who played Rose, same thing with a particle. Same thing, okay? If I tell you, hey, the mass is this much, the charge is negative, the spin is this other quantity, and the spin can either be this quantity or another different quantity. The spin has a couple of discrete states. So it depends which spin state it's in, right? But once I tell you those things, you'll be telling me, okay, my guess is that it's an electron. Or if the mass is more, you might tell me, oh, okay, my guess is that it's a muon. Or if the mass is even more, you might say, my guess is it's a tau, right? Tau particle. So, or if the mass is super low, the mass is almost not there and you're confused, like, oh my God, does this even have a mass? The guess might be that it's a neutrino. But then again, another thing is that how the particles all interact. So the particles that are electrons, muons, and taus will interact with photons. This is very important to remember. So photons are the carriers of the electromagnetic waves or light, right? So E&M, electric and magnetic fields oscillating, that's light. And photons are the quantum state or the quantum nature of light, which light has wave particle duality, matter also has wave particle duality. So another thing too, after you kind of absorb food particles love interacting with photons. Food particles love interacting with photons. Well, yes, food is made of ordinary matter, baryons, and that does interact with photons. Yes, that's correct, Ver. I think you got it. So after you kind of digest what I just said about the mass, charge, spin state, quantum states of all these different particles. So I was giving you examples of electron, muon, tau, but remember that it's also possible for the quarks, the entire quark family, and it's also possible, of course, for the bosons. I keep mentioning photon as an example for boson because everybody knows the photon. It's just light. So I keep mentioning that one. But there are actually other bosons as well. Some other examples of bosons are W and Z bosons. Now, these are the carriers of the weak force. So if you've heard of the weak force, it's one of the fundamental forces. It's different. It's not the same as the electromagnetic force. It's not the gravitation force. It's not the strong force. It's another whole thing. And the carriers of that thing is the W and Z bosons. So the bosons we find are often the carriers of these interactions, and basically the particles are exchanging that boson in order to interact with each other. So oftentimes you'll see that photon is, of course, involved in interactions with things like electron, proton, all of that. And then when it comes to the neutrinos, which is a type of lepton, neutrinos are in the same particle family as electrons. When it comes to neutrinos, they don't interact with photons. So somebody just mentioned WIMPs. That's good. Weakly interactive massive particle. So somebody just mentioned, where is that comment? Thank you for 20 likes. Can we get 30 likes? Oindri Zakami. The stream is way too educational. Okay. Strongly interactive. Strongly interactive ones are called simps. So, you mentioned, Reese, I think, mentioned WIMPs, weakly interacting massive particles. WIMPs are actually a candidate for dark matter. But it's good that you bring this up as we talk about particles, and I think I was just now mentioning neutrinos. The stream is good. She makes it food. Yes, if you think of all of this as food, then I think we're all good. So weakly interacting massive particle is a candidate for dark matter. Why am I saying candidate? Because dark matter is not confirmed. We don't know confirmed like what dark matter is, but we can imagine and think things and hypothesize and try to find such a candidate that we have thought up with various experiments and things like that. WIMP is one of them. So weakly interacting massive particle. Now, the first candidate that people thought of when it came to dark matter was actually neutrinos. So this neutrino particle that I just mentioned is, yes, neutrino is a candidate. Neutrino was a candidate for dark matter as well. Why? Because neutrinos are very, very elusive. So I was just now mentioning certain boson examples, W and Z bosons. Those are the carriers of the weak force. Turns out that neutrinos are particles, they are types of leptons that only interact through the weak force. They don't interact through photons. And they, of course, interact also with gravitation because they have a mass, but it's very low. So for a while, people actually thought that neutrinos might be massless. That's how low mass they are. But because they're so elusive and they don't interact with photons, same as dark matter, you can't see dark matter because dark matter is not interacting with photons. But it is interacting with gravitation. We know that there's this extra matter. It affects gravity, but it does not show itself with light. It does not have a luminosity. So we thought, as a candidate, that maybe neutrinos could explain dark matter. Because what is dark matter? It is a question mark, right? It's a question we have about this extra matter, this invisible matter that we know not what it is. And we're thinking, maybe it's neutrinos. So that was a candidate. But the problem was that the neutrinos were too low mass. Because neutrinos were too low mass, they could not explain dark matter appropriately. And that helped us to come up with a new type of particle. Imagine in our brains a new type of particle. So I want to be very specific what I mean here, right? It's a thought, it's a hypothesis, which is the WIMP, which is what somebody mentioned, which is basically WIMP is exactly like neutrinos, but more massive. Because you can imagine a more massive particle that's kind of like the neutrino, right? If you're, say, looking for one, why not? So that's the WIMP, weakly interacting massive particle. I don't know about SIMP, strongly interacting massive particle, because the strong force is different. The strong force is between the quarks. Actually, the strong force is within the nucleus of the atom. Remember we talked about neutron degeneracy pressure in the context of neutron stars? That particular, so neutron stars are maintained by neutron degeneracy pressure. The force between the subatomic particles are, as in the subnuclear particles, are is actually the strong force. Neutrinos interact through the weak force. Electrons also interact through the weak force. The uniqueness of neutrinos is that they only interact with the weak force. If the neutrinos also interacted with photons, then they would be less elusive, but they don't. Similar thing with dark matter. We see it to not interact with photons, so we're thinking it might be kind of like the neutrino in that sense, but we would want more mass. We would need more mass, and so we thought up the WIMP. But that was a little bit of a tidbit on particles. Hopefully you enjoyed that. And if you have any questions about the particles, let me know. And it came up, I wanted to address it because of something we discussed yesterday. We were talking about the superstring theory, and it is important to understand quantum states and some basic information about quantum mechanics, because it will come up when we further discuss superstring theory. Because remember, superstring theory's motivation is to be a grand unification theory, a theory that can be a broader theory that can encompass more things like particle physics, gravitation, electromagnetism. So, and particle physics meaning including quantum mechanics, of course. Quantum mechanics success leads to particle physics. So if you're going to understand superstring theory, which is a requested topic on this channel, we have to keep in mind that when we discuss it, we have to keep in mind that it has to explain quantum mechanics and particle physics. And that's why I wanted to talk a little bit about quantum mechanics. And somebody had asked yesterday about the quantum states and spin. And spin is a quantum property. It's one of the states or properties of a particle. When identified, it helps you with the identity of that particle. Other such properties being mass and charge. It's like asking 20 questions or playing Guess Who. If I told you the mass, the charge, the spin, you could tell me you're talking about the electron, or you're talking about the photon, or you're talking about the W boson. Okay? Is that helpful, Reese? Is light a wave or a particle or both? It's both. Light has wave-particle duality. Let's talk about that. Light has wave-particle duality. Now, so light is both a particle and a wave. At long wavelengths, light is more like a wave. And at short wavelengths, light is more like a particle. What do I mean by that? As you know, light is possible to be found in various wavelengths, and or same as saying various frequencies. Longer the wavelength, shorter the frequency. Because the speed of light in vacuum is a constant. So since wavelength and frequency, the product of that will give you the speed of light in vacuum. Those are kind of they're inversely related. Longer the wavelength, shorter the frequency, smaller the frequency. So for example, radio waves are longer wavelength type of light. Radio waves are still light. Microwave, my microwave that cooks most of my food, is still light. Visible light, which most of our eyeballs can only see visible light, that's still light. UV rays from the sun is still light. Gamma rays from certain astrophysical events that I like very much are still light. X-rays that are needed in the hospital are still light. These are all types of light. It's the same light, it's still light, but it has different wavelength. It's a different wavelength or a different frequency of light. So when you ask, does light have wave-particle duality? It does. It has wave-particle duality. But you can keep in mind that when you're considering longer wavelengths like radio waves, light will have more of a wave-like nature. When you're considering very short wavelengths like gamma rays, light will have more of a photon nature, more of a particle nature. So if you have super small wavelengths, that will be like super high frequency. Super small wavelength, super high frequency. Like say if you're a Geiger counter, you're constantly getting hit by gamma rays, right? That frequency of getting hit by light particles, it's almost like a wave number at this point. It's almost like a number at this point. You're not so worried now about the wavelength of this light. In other words, the wave nature of light, but you're more worried about, well, how many times did my Geiger counter get hit with this event of gamma rays? And you count that, and that is utilizing the particle nature of light. So light has both particle and wave nature. Depending on your experiment, you might want to leverage its wave nature or its particle nature, depending on the wavelength of your experiment, depending on the sensitivity of your experiment, and depending on the event of interest. Okay? Because something is keeping the halo of galaxies from collapsing. So I think you're talking about dark energy. So the expansion of the universe is due to dark energy. Expansion of the universe is a cosmic effect. It's an effect at cosmic scales, and that is due to dark energy. Dark energy and dark matter are not thought to be the same thing. There might be something with dark matter when it comes to expansion, but that is considered separate. The expansion of the universe is due to dark energy, another question mark in cosmology and in this type of topic. But the thing I just talked about above is dark matter, not dark energy. I know it's confusing. One is dark energy, one is dark matter. But I am willing to talk about it again and again so that we can clarify. So dark matter is felt at a galactic, in our galaxy. It's a galactic phenomena, as well as neighboring galaxies phenomena, as well as cosmological phenomena. So it's something that affects us at various scales, at the galactic scale within our own galaxy, neighboring galaxies, and at large scales as well. Dark energy is specifically a cosmic scale phenomena. It is the cause of the expansion of the universe and its acceleration, as in the acceleration of the expansion of the universe. It is not the same. It is not thought to be the same thing as dark matter. Both are questions, though. Both dark energy and dark matter are questions, but they're not thought to be the same thing. So you need light for the dark to show. Dark matter does not interact with light, so we cannot see it through means like luminosity, which is how we see many objects in the sky, including stars and other galaxies. Okay. I used to be a commie. Seeing how bad things were in the cities woke me up. Stephen destroyed the ship of dreams and snapped it in half. I was also those birds that took down. So it shows itself using the gravitational force of visible matter. So if it's not visible but can be detected, that sparks a lot of curiosity. Yes, exactly. It shows itself with orbitals. There are various types of evidences, but one is the orbital speed evidence. I spoke about that in a previous live, in a few different lives. But yes, it affects the gravitation of visible matter, of other matter in our galaxy, how fast things are moving at various radii from the galactic center. And those things are not consistent with the types of, with the visible matter that we're seeing. We need more matter, and this matter seems to be invisible. So it is invisible, like as exactly like you said. So sparks a lot of curiosity. Exactly, it has. It does spark a lot of curiosity, and it can be studied in astronomy, astrophysics, cosmology, as well as particle physics. So the particle physics way would be to figure out the particle nature of dark matter, and hopefully we do. Otherwise, that would be basically, it's an ongoing research topic. So hopefully we do figure this out. He was homing in on Rose Harper. Light wave or particle, it's both. I'm done. I could have brought up Air Florida Flight 90, but that was a sad. I want you to have a full stream on the Titanic. Okay, good to know. Super sticker. Yes! Harper, can I be a mod? Yes, Harper, you can be a mod. There you go. There you go, honey. You can be a mod. Did I do that correctly? Oh, Harper's already gone. Whoops. Well, whenever they're back, they can be a mod. I just wish someone finds concentrated dark matter so we can cook. I knew that by studying and watching astronomy as a kid. I don't know if I follow. Cats are liquid. Basically how TV remotes work. That's a type she missed. Infrared. Ooh, very nice. Thank you for saying infrared. Like there's night vision, there is light being emitted at night, so night vision goggles see at night. So do radio waves travel further? No. Radio waves are still light. So they travel like light. They have the same speed in vacuum as any other light. They will just have a different wavelength and a different frequency than another type of light, like UV rays or X-rays. Radio waves are also light. It's an example of light. They travel in vacuum at the same speed as the speed of light, which is a constant of nature. Bye, Andre, gotta go. That has to do with the glow of uranium. No super chat. Not yet, unless somebody decides to. It's about the Titanic. We will talk about uranium. Give me 1 second. But I can only give to the legend. Oh, sorry. You're correct. One of the proofs of dark matter was to do with the galaxy's halo. Missing matter, it's extra matter in the halo. Yes, correct. Our galaxy has a halo, and objects in the halo are moving more fast than they should be. So it's not missing matter, it's extra matter, it's more matter, and it's invisible matter. Yes. So I think you were correct. I thought you were asking about the expansion of the universe, but I think you did remember the right part. Or maybe it was to do with the speed of, the orbital speed of objects as you move away from the galactic center. I thought this was a cat stream. What the fuck is this? Oh, whoops, I said the bad word. Hi, Willie. I'm sorry I said that about the miracle on the Hudson. No, you're good. Annie Frank. Can I also be a mod? Thank you so much. Verse says the food references got me hooked. No food references here unless you're referencing. Okay, I think I'm caught up. Willie Dildo. Oh, interesting last name. Thank you so much for being here. Can you please like the live? God. I think my brain is also not working at this point. Classy. Oh my God. You guys will get me. Can we see the kitties? Of course, yes. Oh, here you go. Here's a kitty cat. Here's my Suji mama. Hi, Suji. Hi, Baji. Baji's sleeping over there. Your brain is just fine. She said, oh, Sachi mama, Sachi mama, Sachi mama. Hey, Sachi mama has been giving me so much company and moral support. Sachi mama has been giving me so much company and moral support. I missed Doinder's swearing. Yes! I read a comment and I read the comment instead of filtering the comment in my verbiage, in my verbal delivery. Thank you for liking the live. Where's your stove? I'll show you. Finally, the stream is getting crazy. Beautiful kitties as always. Thank you. I'm still recovering from my own swearing. Not only do I not have a super chat, I even swore. Bon Bon! Hello, love! Hello, Yash! She has to rewire her brain again. Okay. Yes, I never swear. I never swear on the chat, on the live. I don't want to be in trouble. So you asked about the uranium glow. I was trying to go through all the chat messages to see if there was any physics or astronomy questions. My favorite. And so I was doing that weird ADHD type of thing. I'm like focused, I'm reading every chat, going through it. And I read it as is instead of thinking about it first. For a first viewer, I'm glad to have heard that. Yes, it never happens. It never happens. This stream is so boring. It needs to be more boring, Carl. It just got a little less boring. I said the F word. Yash, how are you? Hello, my darling. How are you? Sorry for missing your other lives. My exams were going on. Are you okay? I'm good. I've been a bit under the weather, but I'm recovering. Thank you. How have you been, Yash? Did you see Suji Mama and Baji Baba? I'll show you in a second. Hi, Carl. Hi, Carl. DPW. This stream is so boring. The F word is food, exactly. Deep breaths in and out. Now, about uranium. I do believe. Oh, I see. Reese, take care of this one. I do believe so. Uranium, the glow, if I'm not mistaken, is because of radioactivity. Okay, so there you go. 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 It is because of radioactivity. So So things decay, basically. It's radioactive decay, and that itself will release energy. And uranium is a very heavy nucleus. It has a lot of protons and neutrons. So such a heavy nucleus will have radioactive decay. If you want to learn more about this, I have lives that I have done on Madame Curie's work, Marie Curie, who of course discovered all this and discovered radioactivity, I believe uranium and polonium. I mean, she named this element polonium after her original country, Poland. So if you're interested in radioactive decay, we do talk about it. We have talked about it in previous lives, and I might just read a little bit for you from my Madame Curie book. Sorry, I was typing out a question. What question, Reese? I'm good. And why is the chat talking about swearing? She accidentally read out a swear word. I know somebody said a swear word and I read it as is. Doro went to bed. Guess I'll copy him. You guys have a good stream. Good night, Grimmy. Okay, let me tell you. See, I have this book, The Madame Curie Complex, and let me tell you a little bit from this. So, it was very interesting that she Yes, I try not to say swear words because there are children on the chat sometimes. Many of my friends are, in fact, quite young. Oh, Yash, actually, you might have been here for the Madame Curie Complex live. Were you here? Because I want to read a certain part. Oh. Oh, that's because of refraction. I was going to ask about light. Yes. Yes. So light does not travel at the same speed in various media. So the speed of light in air is going to be different than the speed of light in water, is going to be different than the speed of light in ice and vacuum. Speed of light in vacuum is a constant. But when the light travels from the air to the glass of water, the straw image that you're looking at is the light that is getting bounced to your eyeballs from the straw. And some of that, and that light has been in the water as well as the air. So because, as you said, the speed is different in the two different media, air versus water, there is refraction. So that happens because of refraction. You can look that up. Your friends are young. Good night, Stephen. Okay. Yes. Thank you, everybody, for being here. Lovely to have you. Thank you so much. This was my first live after the super chat and super stuff got activated. I'm very thankful to everybody's support for helping during this journey. I think somebody asked, Oh, I never answered about the time on YouTube. So I've been on YouTube for many, many years, inconsistently, but I've been consistently posting and trying and working since like October. Sort of more consistently since maybe the summer, but like more consistently since October. Yes, John Foster. You asked about the YouTube timing. Yeah, it's been, I've been posting. So if you check on my channel, if you go to my channel, it'll show you like how long I've had it and whatnot. So I've had it, like my oldest videos are very old. Like they're from 10 years ago or something older even. So I used to have like a few videos that I posted a long time ago. Then I started posting like travel and cat videos and things like that too. And I was doing that for a few years, but not as consistently, the lives and everything. And so that started last year, sort of in the summer, and then more since October. I would say really since October is the main timeline. So from October to now, end of February is how long it took for me to get the first level of monetize, or be able to, I guess, be accepted in the YouTube partner program, which this happened literally today when I was at the gym. And then I went live, like my usual, what I do is go to the gym, come back, get ready, go live. So I am still learning about the partner program myself. Literally hot off the stove that I don't use news is that I am now part of the YouTube partner program, like first levels of monetization. There's more levels for me to achieve, but that took pretty much from October to now. Thank you for asking that question though. Thank you for the support, everybody. Thank you so much for being on the live with me. And thank you for asking and participating and engaging and making friends with each other, even if it's Titanic talk. I love it. Love that everybody is finding a community and finding people to chat with. So if our atmosphere is 19 to 22% oxygen, does it mean light travels different in LA compared to a place without smog? Yes. Speed of light will be different in different media. Speed of light in vacuum is a constant, but the speed of light will change if it's in a different medium than vacuum, such as air, water, ice, etc. And in smog, actually, it will disperse a lot. All of the particles in smog will make light bounce off in different ways. So it's not just going to be about the speed of light in LA. It's about the fact that light will be scattered differently in smog. Okay? Smog will affect more things than just the speed. So, as in lots of, it's not that interesting. It's just more scattering. It's going to be more scattering, more dispersion, that sort of thing. If you shine a light through a glass of water, what happens to the light when it comes out the other side of the glass? It speeds back up. Yes, it travels slower in the water. It'll travel faster in air. That's not that long. Yes, from October to now. Baji the handsome kitty, yes. Now I will show you the stove. That's cool. I had a friend post one a while back. I'm glad it's picking up. Thank you. YouTube partner, you can take donations. You can send me a super chat now, Grimmy. A super chat, a super like, or super something else. So yes, I can be paid on these lives now if people do that. So that's the level of monetize that I have now. Thank you for asking. And yes, you can send supers. I'm myself learning about it, and I can't wait to see my first super happen, because then I will know that it is actually happening. Can't wait for you to get a YouTube plaque. Thank you. Smoggy boys, like when the whole cloud lights up when lightning strikes. Okay, so that's a little, that's different. That's because of the lightning is charging the the cloud as well. So that's a little different. The smog talk, if you're wondering, I was being facetious. That doesn't make sense for it to speed back up. That's kind of counterintuitive. So light traveling in different medium will have different speed. Is that what's counterintuitive, you mean? I'm not donating. I thought it was called a button. I'll donate to all Kamala fans. It comes back out of the medium. Yes, yes. Ooh, okay. Let me show you the stove. Where is it? Where's my slipper? Hi, Sachi. Here's Baji. Here's Baji. Hi. Here's Sachi. And here's the stove. It's very pristine because it's not used much. That's scary. You cook. I don't. So we've been talking about the stove that's not used very much. No, the light's slowing down because of the water, but then speeding back up. I'm probably just thinking about it the wrong way. I think, if you think about light being electric and magnetic fields that are oscillating, that might be helpful. So think about electric and magnetic fields literally traveling, you know, through a medium or through vacuum. So electric and magnetic fields can travel through a vacuum, but if they travel through a dielectric, you might know about dielectrics, right? Different media are different types of dielectrics. For example, that's going to affect how those fields behave and the light that you will get from that. Yes, so because light is a wave, and whether the wave is traveling through vacuum or through a medium will change how fast it goes. Okay, but the speed, if this is confusing, forget it, because it's only necessary to understand more regular daily life things like the refraction thing you're asking about. Why are people asking about your stove? Because they're interested in cooking and they want to see my stove that's not used very much. So if the light traveling, I actually did physics, but you're advanced. Stoves are important. That's cool, you did physics. What type of physics? The light that's, you know, going through refraction, reflection, dispersion, scattering off of smog. She doesn't think it's important. I do think they're very important. In fact, they're so important, I'm quite scared of them. Intimidated. Intimidated is the right word. I suffer from intimidation. So Reese, if the light stuff, the light traveling in different medium is confusing, it only affects understanding of reflection, refraction, those types of daily life things. The speed of light in vacuum is still a constant of nature, and that is what we consider in something like special theory of relativity and those other more advanced topics that we have covered. So so if you're okay with light having a speed that's constant in vacuum, then you can understand a lot harder topics. And you don't need to really worry about refraction and straws and glasses of water. That is less important, okay? I'm thinking of it in terms of electricity, so the water would be like an electrical resistance. Food is important enough to cook. Good job. Food is important. I wish I loved to cook. Don't really. These streams are boring to me. I'll see myself out. You lot have fun with Doro. He's a fun dude. Good night, Grimmy. I just did the basics. What about leading time lag? Glasses of water. Reese, think about the speed of... I struggle with understanding these things. That's okay. Refraction is not that interesting. So you could look it up and we can talk about it. So now that I know that refraction is of interest to you, I can definitely try to come up with a better explanation tomorrow. But good to know. Good to know. Good to know. Good to know. It's why my VP ran the country for me. But yes, all right. Thank you. Yes, you can definitely count on this channel for the educational content and the kitty cats. I think Steven is gone now. He's the one who requested the cats, right? They're here. They're here. Thank you so much, everybody, for all your support. Or yet another tarot reader. I should start reading tarot. The channel would be... I actually do like tarot. I don't do it on YouTube, though. Refraction also takes place in the eye, I believe. Yes. Refraction to me means reflection. Reflection? Nice. And did you hide your term in the attic? Ooh, and I never shared the live. 1 second, let me share. Let me share the live. Like the total internal refraction you get going on inside fiber optic cables. Like the total internal reflection you get going on. Simple differences. I know I read your story. Emerald eye. What does that mean? What does that mean? Oh, this? Yeah. Ooh, can you please like the live? If you're so bored, you know what you could do is like the live. That'll give you something to do. Maybe I'll sing tomorrow. What do you guys think? Today I'm a little mellow because I'm still recovering. Enameled. She does 360-degree chair spinning and annoys her neighbors by singing Johnny Cash. Reese, what do you think? Should I sing tomorrow? Maybe I could sing tomorrow. The rainbow effect is caused by refraction and reflection. Yeah, refraction is a big one. Let's see. Oh, I see. I also have super, look, I'm looking at my live on my other phone. You can sing whenever you like. You find it fun, and so do we. Aw, thank you. Thank you. Rudolph the red-nosed reindeer had a very shiny nose. Woke up to go to the bathroom. You guys are still up. Dang, party time in here. My hit list, rich but not rich. Rudolph the red-nosed reindeer had a very shiny nose. And if you knew Rudolph, he didn't have too many friends. I think that's pretty much the story. Dong, 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 dong. And then Rudolph met Santa and helped him with gift carrying. Rudolph the red-nosed reindeer. When I was a child, I wanted to be Rudolph, and nobody made me Rudolph. I just wanted to be Rudolph at the Christmas party, and I'm not even Christian. I just wanted to be Rudolph. Or an extra Rudolph. Rudolph the red-nosed reindeer had a very shiny nose. Oh, Doro, are you here to give me a super chat or super sticker? I'm looking at my live on my other phone and I'm seeing super stickers. Get creative with animated GIFs. Oh my God, it's a thing. Super sticker. Let's celebrate your first super. We'll let the community know about the special occasion. What? Oh my God. Oh my God, it's a thing. Your singing is so pretty. Thank you, Yash. No, I like your stream. Doro. You've made a lot of money. You don't need my money. 11 people and 22 likes. Can we get 30 likes? Super chat. How does this work? Let's celebrate your first super. We'll let the community know. What is all this? Oh my God. Oh my God. What is this? What is this? Oh my God, there's different things. Oh my God. Oh my God. Is this a singing channel? Hi, Monotonia. Hello. 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 I have like negative 750 pounds on the bank, so I'm out. So can I get you to run some XRF XRD? I haven't dropped a like yet because I want to be the one to drop the 30th one. You're holding off on the likes? Are you serious? The likes are free, Ver. Go ahead and like the live. Go ahead. Go right ahead. The likes are quite free. $20 likes are peak. The likes are free. Yes. Pay ya. Did you pay me? Where? Where? I'm the one doing the peer pressuring her. She goes crazy sometimes. Wait, I'm confused. Who is this? Hi, Monotonia. Do you have a song request? I'll sing for you. I do like singing. Do you have a song request? We talked about, see, there's 23 now. Yes, thank you so much. Thank you for liking the live. Welcome to the live. Thank you for staying on the live. Thank you, thank you, thank you. 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 Oh, it wasn't you? Gosh. She goes crazy sometimes. No, not often. Run an independent analysis and I will pay you. Then I waive for you for expert witness testimony in federal court. It wasn't me. Interested, ver. Okay. What song? Taylor Swift? Okay. Ace says pay. Where? Where are you paying? I think a super chat is something when a person sends money to your live or something else. It is, but there's also something called super sticker. There's something called super like, super chat, and super sticker. I don't even know. There's so many things now. I'm so excited. I'm so excited. Yay. Okay. So, let's see. Taylor Swift. Which Taylor Swift song? More cooking, less singing. I will pay you to run a mass spectrography chemical analysis. It's gonna turn into an e-girl. Little clothing and neon lighting everywhere. Okay. Any Taylor Swift song, they're all great. Let's see. Which Taylor Swift song? I already sang Delicate the other day. Ooh, ooh, ooh. Ooh, and by the way, Ace Wolf Peach, I haven't seen you in a while. How come you have been ignoring my lives, huh? How come? Attending doesn't cost money. These people have been attending for free for forever. They've even made friends with each other attending for free. So, feel free to attend. Yes, someone drop a like. Please. Can we get 25 likes? I'll see if I can get Taylor Swift going. Wow. Wow. Grimmy texted me and said he's done. We need someone to replace him. Replace him meaning? Someone drop a like. Thank you. Christina Aguilera is beautiful. Texted me and said he's done. We need someone to replace him. As in he left the job, you mean? Oh, is that why you're so grumpy? 30 likes, please. Yes. Someone super chat. Yes. You lost a viewer. Can you sing Cruel Summer? I don't think so. This and for the best. My reputation's never been worse, so you must like me for me. We can. Let me just re-sing that same song. This ain't for the best. My reputation's never been worse, so you must like me for me. We can't make any promises now, can we, babe? You can make me a drink. It's hard for me to say the drink thing. There is cooking in this song. It's about a drink. Oh no, my eardrums. Dive bar on the east side, where you at? Phone lights up my nightstand in the back. Come here, you can meet me in the back. Oh no, the last line was black. Dark jeans and your Nikes, look at you. Oh damn, never seen that color blue. Just think of the fun things we could do. This ain't for the best. My reputation's never been worse, so you must like me for me. I think tomorrow we're gonna talk more superstring theory. And I don't know if I'll talk about refraction. It's too boring. Refraction? Really? But superstring theory we will talk about. And for that, whatever we need to prepare, we will. Actually, we will talk about I think we'll talk more about quantum. You better not actually like Taylor Swift. I don't. My favorite band is Coheed and Cambria. That clap hit me in the temporal. I'll try to make the others gonna be busy this week. Okay, well, I can still stay on the chat, but I'm gonna go. You guys have a good night and see you tomorrow. Goodbye. If you want to change your mind about giving me money, feel free. Feel free. You have my blessings. You do. You do. You do. You do. Thank you for your presence on this live. Thank you for your presence on this live. Thank you for liking the live. Thank you for being in the live. Thank you for joining the chat. Monotonia, we will sing more next time. Monotonia, please come with your song requests. Send the poor woman some donations. Like and subscribe. Thank you. Thank you for liking. Thank you for sharing. Thank you for subscribing. These are all free. Thank you for your presence. Thank you for your presence. Such as apparently super likes, super chats, and super stickers. Feel free. Feel free to send these things. You are smart. Hi, Mohit. Bye, Ver. Thanks, will do. I got you to 25. Thank you. You made me laugh a lot. Hold it down while I'm gone. Thank you so much for liking the live. Thank you. Bye-bye. Bye-bye. We can still chat. The chat will still be active, so you guys can still participate in the chat. Yay! Yay! Bye-bye.